Yeah, good afternoon. I think this is Faith, Brian, and Ian. Good afternoon.
Good afternoon.
Oh, thank you very much, Faith. Ian and Brian, are you in class? Ian and Brian, are you in class?
Yes, I'm in class, sir.
All right.
Yes.
Yeah, so let me first take this opportunity to welcome you to today's class. When, of course, we shall be continuing from where we had stopped in the last class, yeah? I think it's been 2 weeks. I didn't manage to be with you last week. And so that means I owe you some makeup for the last week class. I had thought I would make up in the course of this just ended week, but time didn't allow. I am looking at options which we can discuss at the end of today's class on when we can make up in the course of the week before the month ends. Yeah. Now, where had we stopped in the last class? Because I can't quite remember. Where had we stopped?
We had done amortization schedule.
Oh, so we had just done the amortization schedule, right? Right?
Yes.
So did we finish that to? Did we finish on that to completion? Did we do that to completion? Did we look at that illustration? Yes, Brian, did we look at that illustration?
Okay, you just came up with a simple illustration which we looked at on how we can prepare a loan amortization schedule. So I'm not sure if it's the one which you're talking about.
Yeah, it's the one I'm talking about. So if we had looked at that, then that's comprehensive for the loan amortization schedule. Yeah, if that is the case, then today I will start on that will mark the end of financial management, and so we'll proceed on to the next unit, which is management accounting. Yeah, but of course in your syllabus that is looked at in terms of just a topic. So the next unit we have management accounting, and so we shall be introducing that. The first thing that note is that under this, we will be required to look at a number of areas. The first one being what we call the cost estimation. The first one being what we call the cost estimation. And then number two, we have the concept of the cost volume, the cost volume, the cost volume profit, the cost volume profit. You know, this is what we commonly abbreviate as CVP analysis. So analysis. And then number three and last, we will be discussing the budgets. So we will be discussing the budgets. And so we shall be looking at the three issues one by one, starting with the first one, which is cost estimation. So cost estimation, that's our starting point. So once we are through with that, then of course we will proceed to CVP, which is number two, and then lastly budgets, which is number three. Now, Cost estimation is also something you have seen on before under management accounting, yeah? And that was discussed in detail, including what methods we use to estimate costs. And what does the word to estimate mean? Which other English words are synonymous with estimate? What does to estimate mean? Let me hear from one or two of you. What does estimating mean?
Approximately.
Yeah, so this is the same as approximating. This is the same as to approximate. What other English words are similar to estimating? So to estimate is to approximate, is also to do what? There are other words similar to this. Yes? So this is the same as also to predict. This is the same as also to do what? To predict. So it's the same as also to predict. So cost estimation is the same as cost approximation. Also the same as cost prediction. So whichever terminology you wish to use, we shall be referring to the same thing. Now, cost estimation is necessary. Cost estimation is necessary for the future costs. The future costs, which are not what? Which are normally not certain. You know, you can only be certain about something at the present or something which is a past, which has actually and already what happened. You cannot be certain about the future. And so as far as, for example, future projects are concerned, you can only estimate the possible what future costs. That is why we have that sometimes we do cost estimation. Now the next thing to remember in this case is that the total cost is the cost to estimate, is the cost to estimate, and this is assumed to comprise, and this is assumed to comprise, and this is assumed to comprise total. This is assumed to comprise a total variable. This is assumed to comprise the total variable cost. Remember that and the total fixed, and the total fixed cost. So under cost estimation, primary concern, remember, will be to estimate the total cost of say a production process. And we shall assume for the reasons of estimating it, we shall assume that the total cost comprises two costs. One is the total variable cost, and then number two, the total fixed cost. We can then write the total cost function as TC, remember equaling TVC, where TVC is total. Let me start with TFC. So total cost is equal to the total fixed cost. Remember that plus the total variable cost. And cost estimation shall therefore be premised on this total cost equation. As we go ahead to estimate our costs, concern will be how do you come up with this which we call the total cost. So of importance is that the total cost, divide that into two parts. One is the total fixed cost, and then number two, the total variable cost. I will continue that for cost estimation reasons. For cost estimation reasons, the total cost function, the total cost function is expressed in terms of a linear equation. So in terms of a linear equation, that is the celebrated this common equation in accounting, that y equals what? A plus now bx. And I want to believe that this is not new to you people. The y is equal to a plus bx is not new in any way. Is it? Is it an equation which we are meeting for the first time really? Are we meeting this equation for the first time really?
No.
Yeah, not really. So these are very common equation in accounting. These are very common equation in accounting. And so we are not meeting it for the first time. And if this is the case, we need to define a few things. We need to define the variables then in this equation. So we say that where when I talk of y, what does y stand for? Y will stand for total cost. Y will stand for total cost. And normally in statistics, we call y the dependent. Normally in statistics, we call y the dependent what? The dependent variable. We call y the dependent variable. And then when we talk of A, A will represent the total what? Fixed cost. A will represent the total fixed cost, so that when we talk of B will represent the variable cost. And on this you have to be careful, yeah? B represents the variable cost per what? Per unit. So B represents the variable cost, the per unit figure, not the total variable cost. Remember, the total variable cost is bx, and bx means b times what? X. So that b alone without x represents the variable cost per what? Per unit. The last one we have x, and x normally represents the activity level. And you know, this one can be in terms of, for example, quantity, or even what? Units. Quantity, or even units. But again, in statistics, we call X the independent. We call X the independent variable. So we call X the independent what? Variable. So we call X the independent variable. Allow me to shed light on two variables here, and let me just highlight them. That's a variable A and B, variables A and B, because our focus as we estimate our costs will be on how to compute the value of A and B. Once in the linear equation y is equal to a plus bx, you have A and B, then you are more or less like you are set to then estimate the cost of whatever activity level. And A and B are normally constants. A and B are normally constants in terms of they don't change. In terms of they do not what? They do not change. So in terms of they do not change. Now, other names for A and B. A, for example, alternatively, in statistics, we shall call it intercept. In statistics, we shall call A intercept. In statistics, we shall call A intercept. And then the value of B in statistics can alternatively be called the slope, or the gradient. The slope or the gradient. So those namings, or these other namings, we can give A and what? A and B. Let me just note this here below, that NB, that estimating total cost involves coming up with, so involves coming up with what? With the linear equation. With the linear equation, y is equal to a plus bx. So estimating total cost involves coming up with the linear equation y is equal to what? A plus bx. Now, deriving this equation, involves calculating the values of what? A and B. So involves calculating the values of A and what? A and B. In other words, to come up with the linear equation, simply compute the values of these variables, which I consider constants. The next discussion will be methods of cost estimation. The next discussion will be methods of cost estimation, and which methods can you guys remember as the ones that we use to estimate costs? Let me hear from one or two of you. Which methods do we normally use to estimate costs? Which methods were you taught about before? Before I tell you which ones, we are required to know in BDA. Which methods can you guys remember? Now, you were taught about a number of methods, but of course, the ones that in BDA we are required to know, one is what we call the high-low. One is what we call the high-low method. So one is what we call the high-low approach. And then number two, we are required to remind ourselves of regression analysis. And then number three and last, we shall be looking at the scatter diagram method or approach. So those three are the ones that are under business data analytics we shall be looking at. Of course, you have other methods like the accounts analysis, the other methods like the industrial engineering. They are normally many. But then we are summarizing that then for business data analytics, we are required to know these three. We are required to know the three. If that is the case, then we will start with the first one. We will start with number one. So we will start with method number one. And method number one, we are saying is the high-low approach. The high-low approach. So that based on the high-low approach, how do we estimate the total cost linear function? In a simple, using the high-low approach, how do we compute the value of A and what? A and B. You know, we have said that coming up with the linear function for the total cost, this is as simple as what? Computing A and B. So how does the high-low approach compute the value of A and B? Now, as the name of the method suggests, we then conclude that the method does what? Picks are just what? The high. Picks are just the high and low values of what? Normally variable X and Y. So the method picks are just the high and low values of X and Y variables, of course, from a set of what? From a set of data. So when you have a set of data for X and Y values, what the method does is very simple. It picks the low and the high values. It picks the low and the high values. Now, what does the method do with the low and the high values? I will continue that using the high and of course low values, the value or rather change in X and Y, change in X and Y are determined as what? So using the low and high values, the change in X and Y are determined as the high minus the low, the high minus the low values. That's how we shall compute change in the value for X and what? X and Y. So very simply check how much is the high value minus how much is the low what? The low value. Now let me continue that using the changes, we then determine value of what? We then determine the value of B as we then determine the value of B as what? As we shall take change in Y, we divide change in Y. So we shall take change in Y, we divide the change in Y by change in what? In X. So once you have the changes, then we are saying that you shall determine the value of B. And you compute the value of B as the change in Y, divide that by the change in what? Change in X. And then we can conclude that the value of A, the value of variable A is then calculated. Let me say that using value of B together with, let me talk over either, together with either the low or the high, together with either the low or the high what? High values. Don't worry, very shortly, we are explaining all these things in terms of an illustration. So what I'll do is this, please go to your WhatsApp group and access the Excel which I'm sending very shortly. Access that Excel and open it, because that's what we'll use to illustrate this. So go back to your WhatsApp group and please access that Excel which I have just sent. So access that question. So what you can do is maybe copy the question to where you have your notes so that it is part of the notes. So copy the question to where you have the notes so that that is part of the notes that we've had so far. Yeah? So I'll have that question there, copy and then I paste. We will say that this is an example. That is an example. So I've copy pasted that question to be part of the notes. Yeah, so once you have done that, you can give me a heads up so that we proceed on. Give me a heads up once you are done so that we can proceed, yeah? Yeah, so I can see Faith confirming that she's done. What about the rest of you? What about Ian and Ryan? Yeah, so you all confirm that you are done, yeah? If that is the case, then we then proceed to add to the question what is required. We then proceed to add to the question what we want to do. And so to the question, let us say that required. Let me say here beside that required, what's required? Number one, that using the high low approach, calculate the fixed and calculate, let me just say that calculate yeah, the fixed and the variable, the fixed and variable elements, the fixed and variable elements in the function, in the function y is equal to a plus bx. And then number two, we'll say that using your results in one above, compute the total cost, compute the total cost of producing let me talk over 400,000 units. So that is the question which we want to solve. All right, so we can then proceed to there below, say that we have the solution. Solution to this. And let's start with number one, yeah? One requires two things, the variable, the fixed and variable. The fixed and variable components. The fixed and variable components. Now, in the linear equation, y is equal to a plus bx. The variable component is the value of b, and we are saying that b is the variable cost, remember, per what? Per unit. So the first component that we need in part one is how much is the per unit what? Now variable cost. And then secondly, we need a, whereby a is the total what? So remember that a is the total fixed what? Fixed cost. So the components which we need, yeah, are there for those two. Are there for those two. Are there for the two. And so that how have we said that we go about this? Now, what we've said is simple. What the high-low method does is that for variables x and y, which I'll have in columns that way, you pick what we have called the high values and also the what? The low values. For variables x and y, look for what is the high value, and then what also is the low value. And so that what do we do with this? We, using these high and low values, we calculate what we call change. We calculate what we call a change. For us to calculate the change, yeah, for us to calculate the change, we first need the high and low values, so that we'll come back to this given information. We'll come back to that information given, and you can see I've defined for you. Of course, in exams, this will not happen, that you are defined for what is x and what is y. So it's you to find out what's x and what is y. But we know that y is the total cost, so that this production cost makes up our y, and so x is the quantity. What is the highest x and what is the highest y? The high x and y is how much? Look at this information. The high x and the high y. What is the most quantity here? And what y do we have that corresponds to it? The high y, the most quantity, is the one for which month? The most quantity is the one for which month? Somebody? The most quantity is the one for December. Yeah, Ian says that the one for December. Yeah, so that's x over 350. Remember against y of 30 what? 36. So I will copy paste that because that is the high x and the high y. So I'll copy paste it here so that high values I then have x 350 and then y 36,000. What about the low values? What is the least quantity? The least quantity, what is it? Somebody? What is the least quantity here? So someone says that the least quantity, we have 90, and 90 is the one for the month of what? August. So again, I copy paste that 90 and the y that corresponds to it. So I bring that here. And once you have the high and the low values for x and y, you shall use the high and the low values to calculate what we are calling what? Change. And in this case, when I talk of a change, when we talk of change, we mean the high value minus the low value. That is what change means, the difference. And so that for x, for example, change will equal how much? Change will be 350 minus 90, and so that gives us 200 and what? 260. The same we do for the y. The same we do for the y, and that gives us 25,000. So that gives us 25,000. If that is the case, we can then proceed to calculate the value of b. We can then proceed to compute the value of b. We can then proceed to calculate the value of b. Now, b therefore equals what? B therefore equals, so how did we say that we calculate b? Once we have the changes, how do we compute b? We said that we compute b as, now this is the formula which we have talked about, that one up there, that b is a change in y, you divide by change in what? Change in x. So I come down here and say that change in y, we have this 25,000, divide by change in x, which is this 260. So 25,000 divide by 260. The value of b is therefore this 96.1538 what? 5. So that's how you compute b. We then proceed to calculate a. You know, those are the two components which we require. Those are the two components which we require. And how did we say that we compute the value of what? A. How did we say that we compute the value of A? Yeah, so for the value of A, we had said before, yeah, that in this last statement here, I said that the value of A is then calculated The value of A is then calculated. Remember, using the value of B together with either the low or the high what? Now high values. Now, our linear equation is in the form y is equal to what? A plus bx. You know, I now want to compute the value of A. And if I make the subject of the formula A, I'll have that A equals what? That A equals y minus the bx. So I'll have that A equals y minus what? Bx. Now, so if you want to compute the value of A, will work with this formula that we take y minus b times x. And we have said that to do that, work with the value of b together with either the low or the high values. Now, this is what we will do. Allow me work with the high values. Allow me work with the high values. Remember, x is 350. And then y, we have 36,000. Then for the high what? Now high values. Now A shall equal what? I will say that equal to, if I am working with the high values, and I'm saying that y minus bx, then I'll take the high y, I'll take that 36,000. I'll take that 36,000. I will minus what? I will minus b times x, so minus bx. So minus b is this 96 point whatever, that which we have computed already. You multiply this by x. Now x, I am still working with the high values. So in that case, I multiply by the high x, so that the high x is this 350. The high x is that 350. What value of A do I then get? If I press enter, I get around 2346.15. And you guys are getting the same figure. Please confirm that you are getting the same figure. Are you guys getting the same figure? All right, I can see in the charts that yes, you are getting the same figure. Now let's agree. If alternatively you work with a B together with the low values also, then you shall still get the same figure for A. If you try working with B together with the low values, then you'll have the same value for A. And so ladies and gentlemen, remember that is it for the two components that the questioner wanted we compute. So that's it. Is there any question? Is there any question?
I have a question.
Yes.
So in this case, it looked kind of perfect, or probably it would always be the same, like for X and Y, where we have the law for X, we have in the same month, we have the same law for Y. or ideally, in some of the scenarios, we'll have to look for the lows and highs separately.
Now, whenever you are looking, no, you cannot look at lows and highs separately. You must look at them in pairs. Okay.
Okay.
If, for example, you are talking about the high values, in picking the low and the high values, you check for X, and then you pick the Y that corresponds to it. Tunaelewana?
Yes, yes.
Yeah, you know, you may have like the high values, you could have maybe the next year, January is also 350, but then you have a different Y. Say Y of how much? Y of, say Y of maybe 34,000. Say Y of 34,000, yeah? In that case, you have, when you check the X, you have what? You have two high X's, 350 and 350. But the costs may differ that way. I am saying if you are looking for the high values, it will mean that you pick the X that has the high Y. So you'll pick the 350 plus between the two Y's, which is high, 36. So that should be very clear. Sawa, Faith.
Yes, that is clear. Thank you.
All right, Brian, did you raise up your hand, Brian?
Oh yeah, sir. I was just confused that just to clarify on what Faith has been asking. Now, in the event that maybe we have a mixture of them, whereby maybe when you see we have a high in units, and maybe that would be the lowest in the product. I mean, the production cost. What if I decide to choose the high in the production cost and which will correspond with maybe something else in the quantity?
I'm not getting your question very clearly.
My question is, can we interchange such that I'm choosing my high from production cost and then my quantity,
No,
whichever number it will align with?
No. As you look for the high and low values, I think I've said this, but I will repeat, yeah? You choose the high and low for X, okay? Then you pick the Y that corresponds to it. You cannot choose high and low for Y and then X that corresponds to it. You start with X. What is the high and low? X. Then you pick the Y that corresponds to it. Sawa. Sawa, Mr. Brian.
Yes, sir.
All right, so that is how we determine A and B in such a set of data based on the high-low approach, yeah? And you know, once you have A and B, your equation form would be Y is equal to what? You know, the equation is Y is equal to A. So A we have said is 2346.15. That's what we've computed. Now plus BX plus BX. B we've computed 96.15. And then of course you'll say that we have X. So that is therefore the cost estimation equation for this set of data using the high-low approach. So this is the predictor equation. That's now the equation that you use to then estimate or predict the future costs. And so that should be it. Number 2 and last ones that we now predict the cost of what? Cost of producing 400,000 units. The cost of producing 400,000 what? Units. How do we get the cost of producing the 400,000 units? How do we get the cost of that? What do we do in this predictor equation? Somebody. What do we do in that predictor equation? Somebody?
Okay, I suppose that in the predictor equation, depending on what we've been given here, we've been given the value of, or we've been given the quantity. So quantity, what we'll have to do, we'll just multiply it by the gradient or by the slope.
Yeah, so in essence, you are saying that we substitute X in this equation with how many units? 400, yeah? That's what you are saying, isn't it?
Yes.
Yeah, so precisely that's what we do. So very simply in this equation, replace X with 400,000 units. So what we'll do is to say that equal to, I pick A, the 2346.15, I say that plus, B is this 96.15. So you multiply that B, you multiply by what? 400. Do not multiply by 400,000, multiply by 400 because our figures were in thousands. If you look at these figures, they were in thousands. Those figures were in thousands, and so multiply by just 400, not 400 what? 1,000. So that please confirm that that's okay. So is that okay?
There was no Mo Salah, there was no Darwin Núñez.
All right, if that's okay, then that's fine. That is it for how the high-low method works. And so I want us to proceed, yeah, to look at the second method. And the second method, method number 2, is the regression. Method number 2 is the regression analysis method, yeah. So the regression analysis method. So how does the regression approach works as opposed to the high-low approach? Now, the regression analysis approach will say that it is statistical. It is a statistical approach to determining A and what? A and B. In other words, so this is statistical. Yeah, statistical. So it's a statistical approach that we use to determine A and B in the linear equation y is equal to A plus what? A plus bx. In other words, you will work with statistics, mere regression statistics, to then calculate now A and B. I will make it very simple that in Excel, this is worked directly. This is worked directly. Let me say that using what? Using what we call the data analysis. Using what we call the data analysis toolkit. using what we call the data analysis toolkit. Using what we call the data analysis toolkit, allow me to call it a feature. There is a feature in Excel that we call data analysis toolkit, and very simply, when you work with it, you determine A and B. All right, now this is what we will do, yeah? Where do we normally find the data analysis toolkit? Where do we normally find the data analysis toolkit? There is a problem with this toolkit in terms of when you look at Excel, you cannot find it anywhere directly. You know, data analysis, under these options up here, data is this option. And when you click on that data, that data thing, you know, you are then taken to the options that you have for what? Data. You cannot find this analysis toolkit directly until and unless you activate it in your Excel. You must activate this toolkit in your Excel. Now, how do you activate this toolkit so that it is readily available under this option that we call data? Now, walk with me through these steps. We want to activate this toolkit. We want to have it readily available under this option, what? Now, data. And how do we proceed to do this? On the left-hand side, on the extreme left-hand side, there is this option called File. There is that option called File. I want you to click on it. Click on the option File. Please work with me very keenly. So click on that option File. And then I want you to pick the last item on the left. You know, on that left-hand side, you have several items. The last one is what is called options. So click on the options. Click on the options. So click on the options. When you click on the options, where have you been taken to? You have been taken to that kind of a window. And so in this window, again on the left, I want you to click on this option called add-ins. Click on the option called the add-ins. Click on it. Actually, double click on it. Double click on it. When you double click on it, you are taken to another window, that which I am projecting. And what are we looking for? We are looking for the data analysis toolkit or tool pack. The data analysis toolkit or tool pack, which you know is one of the options inside here. It is the first one, and so click it so that it is blue. Click it so that it is blue, the way mine is. And once you have done that, so click it so that it is blue. So once you have done that, down here, there is this option Go, down here. So click on Go, click on that. When you click on that, you are brought to this small window. You are brought to this small window. Now, what we want is what we call the analysis toolpack, that first one. So what you'll do is to tick the box before it. Can you click the box before it? Click the box before it. So once you click the box before it, so that it has ticked, on the right, can you click OK? On the right, can you click OK? When you click OK, everything disappears. Everything disappears. But now I want you to confirm this. I want you to confirm this. I want you to confirm this. When you check, I want you to now click on option data up here. Click on option data, that data option. When you now click on the data option, I want you to check on the extreme right up or you. Do you now see this thing called data analysis? Do you now see the data analysis?
Yes.
All right, so what we need for us to be able to carry out a regression analysis is that thing that we've now activated that is called the data analysis toolpack. If you do not activate it the way we have done, you cannot have it readily available here. So as you go into exams, you must know how to activate now that thing. So you very simply follow the procedure which we have what now followed. Once we have that readily available, I want to refer you to a question where we shall illustrate, we shall demonstrate how we then use that data analysis what now toolkit. The question which I want us to do, yeah, is December, the first exam, yeah, December 2020 what? 2022. This is a question number 25. Let's look at December 2022. Question number 2025. Let's refer to that question. Yeah, somebody, anyone who has, any of you who has the question already, can you just screenshot and send it to us in the WhatsApp group so that we see what is there. Yeyote mwenye ashaiona ya screenshot it and send it to us in the WhatsApp group so that we look at it together, yeah? All right. Somebody to screenshot and send that to us in the WhatsApp group. So has anybody found the question? Someone to please send us a screenshot. Yeah, let me just send that to your WhatsApp group. I have found the screenshot. For those not finding it, look at your WhatsApp group. Yeah, I've sent that. So read through the question. Read through the question. All right, so once you have, it's a very simple question in terms of how it's been structured. Now, before we can solve it, yeah, have you guys realized that that information for the cost, the quantity, and the months is the same information which I sent to you earlier? Have you realized that that is the same information? Yes?
Yes. Yes.
Yeah, so it's the same information. So what we will do, yeah, what we will do is copy paste that information again. Copy that information to down there, so that let's have the information here. So that is the same data. And so based on that, we will proceed to then solve the question. Now let us look at what the question wants. When you look at the required, remember we have 3 requirements. And what is the first one? Part A. The first one, part A, we are told that determine the variable cost per unit and then the total variable costs using regression analysis, and that is for 6 marks. Now there should be a correction to that requirement. That should read as determine the variable cost per unit and the total fixed cost, not what the question has said there. So it should be under the total what? Fixed cost. So in part A, we are computing the variable cost per unit, and also we are computing the total what? The total fixed cost. So the variable cost per unit, and then the total fixed cost. Do not forget that the variable cost per unit is the value of B, and then the total fixed cost is the value of what? A. So we are essentially looking for the values of A and B. Now, this is what we will do. To be able to do this, we shall work with what we have called the data analysis toolkit, which we have already activated. And now when you come to option data up there on the far right, you now have the data analysis the data analysis toolkit. So let's open that data analysis toolkit and see how we work with it to then arrive at the two variables, okay? So double click on the data analysis, and when you double click on the data analysis, you are taken to a small window, which I believe that you can see, So that window has a lot of things, a lot of analysis tools. And some of these things you have come across them before, especially in this unit that you had called quantitative analysis or technique, whatever it was, yeah? You came across most of these things like correlation, the covariance, remember, and so on and so forth. You have seen on those things before. Now, the one that we are looking for, and you scroll downwards, the one that we are looking for is regression. So scroll downwards and please locate regression. Once you have located it, just click on it so that it is blue. Click on it so that it is blue. So click on it so that it is what? Blue. So once you have done that, on the right, click OK. On the right, you click OK. On the right, you click OK. I don't know whether yours has behaved like mine because it has not done what it should. So it should be I double click on data analysis. All right, so it brought what I want. When you've clicked OK, have you been taken to the window that you are seeing on my screen? Yes?
Yes.
Yes.
All right, so that's what we want to work with. That's what we want to work with. Now, what does this window say? This window says that the first thing to do is to input Y range. What do we mean by Y range? Y range are the values of Y. And the values of Y we said is this production cost. So you highlight all of them. Hapo kwa input Y range, highlight all the values for the Y. Input Y range. The next one is to input X range. So take your cursor to input X and then highlight the values of X. Values of X are the quantity in units. So again, highlight all. Highlight all. Ideally, that should be it. Ideally, that should be it. But let me just explain one more thing. Let's look at part B of the question. I want us to go to part B of the question. What are we told in part B of the question? Go back to the question. We are coming back to this window very shortly. Part B of the question says that estimate the total production cost if the following number of units are what? Produced. One, we have 100,000. Number two, we have 150,000. Number three, we have 200,000. My attention is drawn to the last statement in that part B. We are told that include the lower and the upper boundaries at what we call 95% confidence now intervals. Now this is the thing. This is the thing. One of the options in this window is this thing that we call the confidence level, which can also be called the confidence interval. And you can see that by default, Excel gives you 95%, and that's what the question wants that we include. Now, this is the thing. By default, Excel will give 95%, but you know, this confidence thing can be another percentage, not necessarily 95%. What if, for example, you are told to include 99%? You may have to change this. And to change this, you will click the box before that confidence level. When you click the box, the percentage becomes changeable. So you can change that to say 99, you can change that to 100, you can change that to 50, you can change it to whatever percentage. In our case, let us stick to 95 because we were told to include 95.
Excuse me, sir.
Yes.
So, according to what you're saying, I can see that we've been told to maintain it at 95%, but literally, I don't know what it transforms to or how to interpret it in real, like now when it comes to reality, because
Now
I can only see that I can change it to 95, but I don't know what it translates.
You don't know what it is. This thing you were taught about it in quantitative analysis and techniques, yeah. And really, you are required to remember some of these interpretations. Of course, what this means is simple. When you know, we are doing cost estimation and we are estimating figures. Like when we come up with the value of A and B, those are estimated what figures. The confidence level looks at what amount of confidence you have in the estimated what figures. Okay, you cannot have absolute confidence. You cannot say you are 100% confident about an estimated figure. You can only have a given level of confidence. You are 95% confident that the A and B computed will be those figures. What the confidence levels work on is to provide a range within which that confidence apply. Like if it is the value of A, you'll compute it, but say that it is within this range, so much value of A and so much value of A in terms of an upper limit, a lower limit. So it is within those limits, that range, that you are then confident that you are then 95% confident that the figure will be so much. Let me get to explain more on this once we have computed these figures. Sawa.
Okay, I've understood that, sir, but please, before that, could you kindly pass us through this other checkbox, just an interpretation for us to get an in-depth understanding of, because you see, most of the time we may be told to do something, but since you do not know the interpretation or the question have told you to do something, but yes, we have it on this table, but we can't really click on it because we don't know what it can translate to. So can you kindly pass us through other checkbox?
I do what?
You enlighten us on other checkbox, such as maybe when we tick on residual or on residual, what it can transform to and other things like that, kindly.
Which residual?
Like in this box, which are displaying.
This one.
Yes, like you see, there are other checkboxes which we can see. So I just needed you to enlighten us, maybe the same way you've done with the confidential level, just to explain to us so that we can get an in-depth meaning
No,
of
you,
all
you
this.
see, we have to restrict ourselves to just regression, yeah? Otherwise, those other ones, you don't need them. They are not in your syllabus. Eh? So if I go into explaining those others, maybe we explain once we are through with the syllabus. We do not have time, eh? So could you allow that I first clear what we should? If time allows, then we can go into those others which we do not need. You see, in all those options, those analysis tools that we are talking about, yeah, like the correlations and so on and so forth, they are not part of your syllabus. And so even if we explain them, fine, that's a bonus. But let's do that once we are through with what we should do. We are time limited. And so on that note, you'll allow me to just be strict first on what we need to cover. Then if time allow later, we can, but most of these things are things that you can read on. You know, Google has everything, yeah? And so ideally, at this level, you cannot be taught everything. Yeah? So for now, let us restrict ourselves to just what we are required to do. If time can allow later, then we can shed light on those other issues which you are talking about. So for now, let's restrict ourselves to, of course, what I've planned that we do. Sawa. Okay. All right. So we were at a point I was explaining about this confidence thing, yeah, that you can change that percentage to whatever percent, as of course exams will specify. Sometimes you can be told to work with 99% confidence, so you need to change that appropriately. Of course, in our case, part B wanted we include 95%, so leave it at that. On the right of this box, there is OK. Click OK. Click OK. So click on OK. The moment you click on OK, now something happens. The moment you click on OK, something happens. Look at what happens. You are taken to a different sheet. You know, you move from the sheet ile ulikuwa, you are taken to a different sheet. And in that different sheet, you are given this thing that is called summary output. That's what you are given. And ladies and gentlemen, that summary output has the answer to what we want. So that summary output has the answer to what we want. Now what we'll do is this: copy that information. Let us take it to where we were solving the question. It will happen by default that information, it will happen by default that that summary output will be given in a different sheet. It cannot come to the sheet you are working on before. It will come as a different sheet. So copy that information. I want us to paste it under where we are doing the solution to this question. And so, what is the answer to part A? You know, part A wanted that we determine the variable cost per unit. We know that this is the value of B, so we are looking for the value of B, and then we are also looking for total the total fixed cost, which we know is the value of A. So we are also looking for A. And I've said this: those values are in this information summary. Those values are in this summary output. And please pay attention. The last column in that summary output, we have this information. This one here. The last part of that summary output, we have that information. Pay attention to this column called the coefficients, the one that I have in yellow. Pay attention to that column. Now, what other name did we give the total fixed cost A? Who remembers what we said is the other name for A? We said that A is the total fixed cost, but what else do we call it in statistics? What other name did we say that we call A in statistics?
Intercept.
The intercept, yeah? And so you realize that for the coefficients, the first variable is intercept, this one. And so let's agree that the value of A is this intercept, this 3977 point whatever. That's the value of A. And then friends, the value of B we know is the variable cost per what? Per unit. And that is what in this information is called X variable 1. This X variable 1, this 95 point whatever, that is the value of B. So that is the value of B. And so we conclude that under regression analysis, that is the answer to part A. That is the answer to part A. Is there any question? Nani yako na swali? All right, now this confidence level thing, like I was explaining before, the confidence intervals is a range of figures within which you are confident that the constants, that the value of the constants will remain so. And confidence level establishes two levels. One is what we call an upper level, and then number two is what we call a lower what? A lower level. The upper level will give you the highest possible value for the variable, whereas the lower interval will give you the least possible value of what? Now the variable. Look at this. Look at this. Look at this. The normal values of A and B are these ones which I have here. What I've said is the solution to the question. But this information has these two other things. This information has that lower 95% and then upper 95%. What do those lower and upper mean? What they mean is simple. That the normal A and B are these ones that we call the coefficients. But within our 95% confidence, we are saying that the least possible values of A and B are the ones under this lower. And by the way, when you check those values under the lower against these coefficients, you find that they are less than the coefficients. the lower level must always be less than the normal figures. And then for the upper, you now have the highest values, the highest possible values of A and B. And for the upper level, the highest level, you realize that these values are now more than the normal or the coefficients. And that is what the 95% confidence level does what now means. If that is the case, we are through with part A, so that should have earned someone 6 marks. 6 marks, yeah? Let's proceed on to part B. Let's proceed on to part B. So we proceed on to part B. And what does part B want? Part B says that part B of the question reads that estimate the total production cost if the following number of units are what? Produced. We are looking for total cost of the following units. I will have a column that I will call units, and then I'll say that I have their normal total cost. The first quantity, number 1. The first quantity, number 1, we are told that we have 100,000 units. Because the figures were in thousands, just work with 100 only, not 100,000. The figures were in thousands. And then the next quantity, number 2, is 150. And then the next quantity, number 3, is how much? The next quantity, number 3, is 200 what? Units. We have already demonstrated how you compute total cost. The total cost of a number of units is equal to what? Like now for 100 units, the total cost is the 3977 point whatever. You know, we say that plus bx, A plus bx. So that 3977.63 plus b, which is 95, but then times x is the number of units which are 100. So x is the number of units which are 100, and so that will give us a total cost of about that 13 something to 2 decimals. That is 13,494.85. Proceed to compute for 150 units and 200 units in the same manner. Compute for the other units in the same manner. Yeah, so please confirm that you are getting the same figures as what I have, yeah?
Yes.
All right, so if you're getting the same figures, Yeah, that is it for the normal total costs for the three quantities. Now, but you know, we are not yet through with what that question wanted. The question says that we include the lower and the upper boundaries at the 95% confidence interval. And I've said that the confidence interval introduces two limits, what we call the upper limit or interval, and then the lower limit or interval. So what the question means by we include the 95% confidence intervals is that we also compute the lower, total cost. That is now the total cost at the lower 95% confidence. And then we also compute the upper now total cost. Remember, at the lower and the upper confidence levels, we have different values of A and B. The values of A and B change. So working with now those new values for A and B at those intervals, how much total costs do you get? So we proceed to compute in the same manner. Like the lower total cost for the 100 units will be the lower total fixed cost of 916 plus B is 81. I multiply by what? By 100. I multiply by 100. And so if you are to compute in the same manner for the other units, if you are to compute in the same manner for the other units, what we get is those are the amounts that you get: 9,000 and then 13,000 and then 17. And then for the upper total cost, that will be the total fixed cost at the upper boundary plus the variable cost per unit times the number of units. That gives us 17,969 for 100 units. And then in the same manner, we compute for the other units, and so that for the other units, that's what we get. So finish up and confirm to me that you have the same total costs. Confirm to me that you have the same total costs. All right, so we can continue, yeah? So did you guys, did you get the same figures? Are you having the same total costs as mine? Yes?
Yes, though I have a question. So once I do the first one and then I drag, I've noted sometimes I get the correct result, and at times when I drag, I get wrong figures. So I'm not very sure where I'm going wrong with the dragging, just the dragging part.
Faith, do you have another question?
No, just that.
That's about Excel, yeah? You know, that is just about your mastery of Excel, okay? So you can work on that later in terms of, you know, that is just an issue of Excel. If the dragging is becoming problematic, then you can just do moja moja. Moja moja. Yeah, but if you know when to, for example, lock the constants and those kind of that kind of a thing, then it should not be an issue. Yeah. Let's look at what part C of the question wants, and part C of the question says that we plot a chart, or rather we prepare a chart plotting what is called the predicted y versus the actual y from the regression function determined in A above, and then interpret your answer. Yeah. So we want to plot a chart. We want to do a chart plotting what the question calls the actual y versus predicted y. So a chart plotting actual y versus the predicted y. The actual y must be part of the actual information which we had before. And remember that our actual information was this data. Actually, what I want us to do, let's copy that information and have it down there. You know, when you are told of the actual y, that must be, actual y must be from our actual info, and our actual info is this. In this actual information, we had agreed that y is the production cost, and so the production cost is what we are now calling the actual what? That's now the actual y. So actual y is that information. The question says that we plot a graph over this actual y against the predicted y, and you know, for the predicted y, that is now the total cost. Remember, predicted based on this function values that we've calculated in part what? In part B. Remember, even these total costs that we have computed here, they are predicted costs. These are predicted total costs based on the function values which are here. When the question says that we use our answer in part B, then we shall work with the normal A and B. Based on the normal A and B, how much y do we then predict per month? So I'll have a column which I'll call the predicted what? Y. I'll have a column which I'll call the predicted y. So I'll have a column which I'll call the predicted y. Now, in this case, we shall be predicting cost. We know the total actual cost. We know the actual total cost per month. But the question is now saying that again per month, can we predict a Y? We predict the total cost based on the predictor equation. And the normal values for the predictor equation we said are this. Look here, we shall then work with that A and B to predict total cost. When what is our X? When our X are these actual quantities. You know, for this actual Y, the quantities are this. If we then try to predict the total cost of the same actual quantities, what predicted Y do we get? What predicted Y do we get? Like now for the month of January, you know the total fixed cost is this 39.77. You say that plus B is this 95.172, but then times X, where X is January, this 150 units, where X for January, we have the 150 what units. So the Y that we predict for January is this 18,253.416. That's what we predict. So the actual Y was 18. When we predict based on the predictor equation, we are getting a predicted Y, which is this 18. And if this is the case, we need to compute for the other months in the same manner. Yeah? Faith, are you still in class?
Yes, I noted I was skipping the locking part.
Yeah, you have to lock. Like now you have to lock this one, then drag, yeah?
Yes.
Yeah, so first lock the constants before you drag. Yeah, so just use that locking thing to lock the two constants, to lock A and B, and then drag the formula, and then drag the formula to the last month. So those are the values of the predicted Y. Those are the values of the predicted Y. So those are the values of the predicted Y. So obviously the first thing to do is to compute the predicted Y. The way we have, the first thing is to compute the predicted Y, so that the actual Y, we readily have that, and then we have quantity. Can we now plot a graph comparing? Can we now plot a graph comparing the actual and predicted Y against quantity on the x-axis? I've already taught you how to come up with a graph, yeah? And so that should not be an issue. I've already taught how to come up with a graph, and that should not be an issue. That should not be an issue. So can you guys remember how to construct a graph? Do you guys remember? Eh? Do you guys remember how to construct a graph? Yeah, so I had said that just hapo kando, you can just click on any cell. Just click on any cell and then go to under insert up there. Graphs are normally under insert. So you click on insert up there. The graphs or the charts are somewhere hapa katikati. Let's work with the line graph. Let's work with the line graph. So you click on that line and then pick on the first option. The first option, pick on that one. So I click on that first option. As soon as I click on the first option, I'm given a chart area. I'm given this box where my graph will appear. So that's called a chart area. So as you can see, it is totally blank because we have not yet put any data in that graph. If that is the case, then you will put your cursor within the chart area and then right click. When you right click, you are given options. One of the options is this one called select data. This one called select data. So I'll click on that one and then I'll be taken to that window. I'll be taken to that window titled select data source. The data source is the data that we want to plot. And on the left, you have this add option where we add the data for the values of y. So I'll click on add. And so when I click on add, I'm taken to a smaller window, edit series. Under that, I have series name. So the first y that I want to plot is the actual y. So I write under the series name that actual y, and then series values, I highlight the values of the actual y. And then I press, and as soon as I do that, you can see that my graph begins to form. Your graph begins to form. Then of course I press OK. So I'm taken back to that window of still select data source. You know, I have two y's, the actual y, which I want to predict, which I want to plot against the predicted y. So again, I press add. On the left, I add another one. The series name is now the predicted y. And then under series values, the same thing. I highlight all the values of the predicted y, and then I press OK. On the right side of the same select data source window, you have edit. On that edit, you now put the values for the x variable. And x variable is this quantity. You know, the costs are plotted against what? Quantity. So what will it do? What will it do? For the x, you realize that you have nothing like the name. All it wants is the axis label range. Axis label range are the units. So I highlight all the units. I highlight all the units, and then I do OK. I do OK. I'm taken back to that window again, select data source window. Down there on the right, you have OK again. So click that OK. As soon as you do that, that's our graph. That's our graph. Yeah, so that is it for how regression analysis works in that's how the regression analysis works, of course, in estimating cost. Yeah. That's how it works in estimating costs. And so with that, I want to proceed to the last method of cost estimation, and the last method, which is number 3. The last method, which is number 3, we said is the scatter graph or scatter diagram method. Yeah, the scatter graph or the scatter diagram method. So how does the scatter diagram estimate our linear equation? And you realize that when you come to where we have the charts, so up there under insert, when you click on option insert up there, one of the charts is normally this one here. Yeah, I hope you can see it. Can you guys see what I'm pointing? Eh? Are you seeing what
Yes.
I'm pointing?
Yeah.
Yeah, you can see that is called insert scatter for X and Y or bubble chart. So a scatter graph is a graph. This method involves doing what? This involves plotting points for X against Y. For X against Y variables on a graph. So it involves plotting points for X against Y variables on a graph. For the points plotted, a line of best fit is determined, and a line of best fit, fit is what in statistics we will be calling a trend line. In statistics, we shall call it a trend line. So you start by plotting X against Y variables on a graph. Once you do that, you'll end up with a graph with plotted points. Now, what will happen will be that for the points you have plotted, you will fit what we call a line of best fit. A line of best fit is the same as what in statistics we also call a trend line. Now, for the trend line, the linear equation, y is equal to a plus bx. Y is equal to a plus bx is so for the trend line, the linear equation y is equal to a plus bx is determined. So a linear equation, y is equal to a plus bx is what? Is determined. I want to illustrate how this method works very quickly. Let us say that we have example. Of course, what Excel does is to do all this automatically for you as long as you know the procedure. As long as you know the procedure. Now, I want the same information as we've had before. The same information of the month, the quantity, and then the production cost. So I'll copy that and have it down there. Still as my example. So I need the same information, and then I'll add to it what is required. So let the required include number 1, prepare. Number 1, prepare a scatter graph. Prepare a scatter graph for this information. Number 2, include in the graph. Include in the graph the following. Include in the graph the following. The first one, A. Let me call it a trend line. The first one, A, is a trend line. And then B, the linear equation. The linear equation for the data. Now C, there's something that we call R squared. And you guys should be remembering this thing from your earlier studies. If you do not remember, go back and revise on what you had been taught about the R squared in quantitative techniques for analysis. Yeah, here what we are required to do is to know how to show it on a graph. Otherwise, for the interpretation, look for your notes for QT, quantitative techniques or quantitative analysis. Now, lastly, I want us to carry out a line test. Carry out a line test for the trend line. For the trend line above. So carry out a line test for the trend line above. I'll explain what this line test means. So let's first look at the first requirements. And then when we get to part 3, I'll explain what the line test means. One of the things that you are required to know. Now, let's agree, lady and gentlemen, that this is now a simple graph. So we don't need to go that long procedure that I had used before. For a scatter graph, so that we have solution down here. Remember, Excel comes up with graphs automatically. You don't do anything manual. So for a scatter graph, now this is now a simple graph because we are simply plotting this quantity against cost. So just 2 variables. In that case, what you can do without the long procedure, just highlight that info, highlight that information that way, and then go to under insert, where you have graphs. Go to under insert, where we have graphs. So where we have graphs. So where we have graphs, under the charts, under the graphs, look for this one, this scatter, the one I had showed you before. The one I had showed you before. The one I showed you before. The one that I showed you before. Now click on it so that you are taken to which options do we have, so that we are taken to the options that we have. Now pick the first option, the one with just the points, without any line. So pick the first one, so click on it. When you click on the first one, remember, you have your scatter graph. That's a scatter graph. So that's a scatter graph or a scatter chart. So a scatter chart or graph, very simply, shows the points plotted for X against Y. Just the points are shown in a scatter graph, nothing more. So that is what amounts to remember what we call a scatter what? Graph. Look at what the question says in number 2. So with that, we are done with number 1. The question says that we include in the graph the following. 1 is what we call a trend line. Number 2 is what we call a linear equation for the data. And then number 3 is what we call the R squared. A trend line is a straight line that passes through these points, showing the trend for this data. You know, in cost estimation, we deal with a linear equation, a straight line, a linear equation, a straight line. So what straight line will best fit now these points? That straight line is what we call a trend what? A trend line. And this is what we will proceed to do. You are going to have your cursor within that chart and click on any one of the points you have plotted. When you click on any one of the points you have plotted, your graph turns to be this way. The points will be looking as if they are stars. So once you have done that, where you had the point you had plotted, proceed to right click. Proceed to right click. Proceed to right click. When you right click, you then have those options: delete, reset, change. Look for add trend line, the second last one. Add trend line, the second last one. Now click on add trend line. Click on add trend line. Now, when you click on adding the trend line, two things happen. When you click on adding the trend line, two things happen. Like in my case, there is a straight line drawn on the graph. There's a straight line drawn on the graph. That straight line is what we call a trend line. That's what we call a trend what? A trend line. The linear line for this data. That's the trend line. The question wanted in the same part 2 that we include in this graph two other things: linear equation for the data, and then what we call the R squared. Where do we get these ones? Now, in addition to the line being drawn, the second thing, you are given this other window where you have format trend line. Format trend line. Scroll to the last part of that window. Scroll to the last part of that window. Now, when you do that, you have the last two items under those options. You have the last two options. One, you are told that display equation on chart. and then also display R squared value on a chart. What you'll do is to enable those two things. Click the box before display equation on the chart. As soon as you do that, look at what happens to the graph. The graph already has that equation, and then also click on the box before display R squared value on the chart. As soon as you click that as well, then the chart or the graph again immediately shows the R squared. So that way we have done what the question wants in part 2. We have included in the graph the trend line. We have also included in the graph the equation. And lastly, we have included in the graph the R squared. The R squared. And so because that is it, I will cancel this format trend line options. So that's my graph. That's my scatter graph showing importantly, first of all, the points. Secondly, the trend line is the straight line. Thirdly, the equation is y is equal to 95.172x plus 3977.6, and then also the R squared. Allow me to ask, are we familiar with these figures in this equation y is equal to whatever? Do we know those figures?
Yes.
Yeah, they are the same figures that we computed in part what? They are the same figures that we computed under the regression. Under the regression, the normal figures for A and B. They are those figures. And if that is the case, then we are through with what? We are through with part 1 and part 2. The last part says that we carry out line test for the trend line above. What does line test mean? Remember that something like this kind of a graph happens in practice. And so you could be the head of your finance department, and then your junior presents to you this data and tells you that the data represented on the graph is that graph. You know, sometimes so that they show you a good picture that probably the company is not doing badly, you may find that this data, or rather this graph, is prepared using data that depicts a better picture compared to your actual data. So that means that they can lie on the graph and give you a graph that presents a better picture than the actual data. How do you confirm that this information in this chart is actually as a result of this actual data? How do you confirm that this chart has not been doctored so that you have what? So that the data is lying. How do you confirm that this graph is actually as a result of this data? For you to do such a confirmation, you carry out this thing that we call a line test. You carry out what we call a line test. The line test is carried out. The line test is carried out. Line test is carried out using a function in Excel that we call linest. Linest. Linest is the short form of line test. You use a function that you call linest, the short form of a line test. Now, how does this test work? Look here. Whenever you work with a function, whenever you want to compute anything using a function, you start with an equal sign, and then you type what you want to compute. Like in this case, we are looking for the linest. So equal sign, and then you say linest. Now you will have the open bracket. As soon as you open the bracket, Excel tells you what to do. Excel says that first of all, look for the known y's. More or less like it is saying that, can you look for the values of y? In this actual data, the values of y are this 18 all the way to 36. So I highlight all from January to December. From January to December, and then comma, and then comma. Excel then says that you now go for the values of x, and so again I will highlight the values of quantity x, values of quantity x, and then of course I close the bracket. I close the bracket. If I press enter, look at what I get. Look at what I get. Look at what I get. I get some 95.17217. Now, what I do next to then confirm that this data is actually, or rather this graph is actually as a result of this data, I check whether this value I get in this line test, this 95 point something, is it in this equation displayed in the graph? And when you check, the equation is y is equal to 95.172. 95.172 is what we have in this line test. So the moment that is equal to what you have in the equation in the graph, then that's a confirmation that this graph is actually as a result of this actual what? Data. In case the graph was doctored, then you will not find the same figure for this line test as what you have in this graph. So that's how you carry out what we call a line test or the linest or the linest. Is there any question up to that point? Is there any question to that point? Is there any question to that point? Yeah, so if there's no question, now all those things are examinable. Actually, all these things have once in a while been set before. So you must know all those things because they are all examinable. Now that means we are through with the topic management, not management, but the topic cost estimation. So that next we shall be looking at the second area under management accounting, which is the cost volume profit. This is what we commonly call CVP analysis. So CVP analysis, and so ladies and gentlemen, I think unless somebody has a question, then we shall be stopping there. Nani yako na swali? Is there any question? Yeah, so if there's no question, then allow me to say thank you very much. Now, when can we have the makeup for last week? When can we have the makeup for last week? Yes?
So are you available on a weekday or on a weekend?
I'm available on weekends are tricky because you see Saturday I'm not available. Sunday we have a class, so we cannot have the makeup on Sunday. Weekdays are the only viable options, but now the time is very tricky. Like I used to meet you guys, I've always done my makeup on Tuesday and Wednesday in the evening, but now unfortunately again I'm not available. I'm not available now. I'm not available on Tuesday and Wednesday at those times because we normally meet at 8:30 to probably 10, but I'll not be available. I'm not available. What time do you guys leave work? Yes? Do you leave at 5 strictly or earlier?
I know, usually when like by 7 when you get home.
Yes?
Usually we can get home like at 7, if
Or
you
you get home
consider.
at 7, yeah?
Yeah.
Okay. Now, what I'll do is this, I will communicate tomorrow on the possibility of Tuesday and Wednesday, just like we have done before. So I'll talk to you guys tomorrow in the WhatsApp group. Yeah, is that okay?
Yeah.
That's okay.
Let me work on the arrangements. Then I talk to you guys tomorrow.
Okay.
Yeah, and please remember, we do not have time. We still have a good chunk of the syllabus to go. Make sure that you keep up with practicing on what we've done so far. Don't pile these materials until the last minute. That's when you want to go through them. You know, this is not the normal reading, like you've done in other units in CPA. These are practical units. So you must keep practicing in Excel, always practicing, yeah, so that you be well conversant with these things. So please do not keep everything until the last minute. Keep reading before we meet for the next class. Go through these things that we've done today. Think that way, you'll make life easy for you. So that is it. Thank you very much, ladies and gentlemen. See you guys on Tuesday. So tentatively, we are meeting next on Tuesday at 8:30. So tentatively, we are meeting next on Tuesday at 8:30. Yeah. So asanteni and enjoy the rest of your Sunday.
Thank you.
Thank you so much.